be learning about the properties or the let's say reactions of the alcohol. So in the reactions of alcohol, mainly we will be covering three categories of reaction. So let's write those part that what are the categories of reaction which we are going to study. So next, that is in the reactions of alcohol, we have to cover the first one, that is referred as the reaction due to OH. That is because of this hydrogen, that is acidic hydrogen, there will be reactions. Then the second one, that is referred as the reactions due to the CO bond, that is because of the reactions will be taking place. And the third one, that is referred as a miscellaneous type of reactions. So there are three categories of reaction which we will be covering. Okay, so the first one, that is reactions due to OH, second is reaction due to CO, and the third is referred as the miscellaneous. So coming to the first one, that is due to reaction due to this OH. So the first one, that is a reaction due to this OH. Therefore in this way we will be having four reactions. The first one, that is referred as this acidic nature, because of this hydrogen which is having acidic nature, we will be having the reaction. Then the second one, that is due to action with the Grignard reagent. Then the third one, that is third type of reaction, that is referred as esterification. And the fourth one is referred as the Williamson's ether synthesis. So these are the reactions which we are going to study. Now coming to the first one, that is referred as the acidic nature, that is due to the acidic nature we will be having these reactions. Now in acidic nature, what we are having is ROH, that is referred as a weak acid. Now why it is a weak acid? That is because of this R group. R in here is a plus I group, it is a donor. So donor means it will be making this OH bond stronger. If this OH bond is stronger, then hydrogen removal will be difficult. So it is, as this R group, that is the alkyl group, is plus I, therefore this is referred as a weak acid. So if it is a weak acid, it is going to react with a strong base. So this is ROH, that is in a reaction with first one, that is metal, that is sodium. So it will be forming RONA. Along with that, it will be releasing the hydrogen gas. Then the second one, that is reaction with NaH, which is referred as a strong base. So again it will be forming the same thing, that is RONA, and again the hydrogen will be released. And the next one, that is with NaNH2, that is also a strong base. This reaction again the same thing, RONA, and the hydrogen gas will be, so in this case the ammonia gas will be released, because this is NH2. NH2 will combine with this hydrogen, so ammonia will be released and RONA will be obtained in this one. So these are the three reactions due to the acidic nature of this alcohol. Now after the acidic nature of alcohol, the next reaction is with the Grignard reagent. So next one, that is the second one. So second, that is action with this Grignard reagent. Now in the action with this Grignard reagent, we will be having this Grignard reagent which is referred as R minus MgX with a positive charge on Mg. So this is the compound. Now this is basically a reagent. This reagent on reaction with alcohol. Now alcohol has this hydrogen. If this hydrogen is present and it is referred as a acidic hydrogen, then this acidic hydrogen will combine with this R group and MgX will combine with this RO minus. Therefore it will be leading to, that is RH, this R combined with this hydrogen, so that is RH. Along with that we will be having the Mg, which will be combined with X is already there, and RO minus. or we can refer it as R dash. So it will be combined with OR dash. So it is a alkane. Along with that, the another one which we have produced, and that is referred as magnesium haloalkoxide. So that is the product in here, that is action with the Grignard reagent. Now this reaction can also be used to identify the number of OH which is present in this case. So if there is only one OH, it will react with one equivalent of this Grignard reagent. If the reaction has two OH, it will react with two equivalents of Grignard reagent, and so on. So we can write that this reaction can be useful in the identification of the OH numbers which are present in the alcohol, that how many OH group are attached in that particular alcohol can be identified through this reaction. Okay. Then the third is referred as esterification reaction. So next is esterification reaction. In the esterification reaction, we are having the acid which is RCOH in combination with this alcohol. It is going to produce, in presence of a acid, it is going to produce a ester which is RCOR dash. Along with that, there will be release of water, and this is a reversible reaction. So let's look into this mechanism, that what is happening in this case. In here we are having the acid. Acid is what? Carboxylic acid, to RCOH. In this we have added acid, that is H plus. Now H plus will combine with this oxygen. So in this case we will be getting RC double bond H with this OH and OH. Now next one, that is with R dash OH. R dash OH we are having this particular oxygen with lone pair. Now this lone pair will come and attack on this, and this wall will be open. Therefore R with carbon with OH, then another with OH, and this side we will be having OR dash with hydrogen bond. So this is the reaction, and this is the positive charge. Now this proton will shift to this OH group. Therefore we will be having RCOH. Then in this one we are having OH2 plus with O and R dash, that is attached to this one. Okay, so this is the compound. Now this oxygen has lone pair which will come back, and this water will be removed. So in the next step we will be having RC double bond OH with a positive charge and with that OR dash. Now there is a hydrogen which can be removed. So removal of this proton will lead to the formation of RC double bond O OR dash group, which is basically a ester. So this is the final product which we have obtained, which is the ester, and this reaction has a fruity smell. Now why it has had fruity smell? Because this ester has the fruity smell, which is the product. So this is a reaction in which esterification is taking place. Now in this case what is happening? From this acid, that is RCOH, this OH is combining with this hydrogen as per the mechanism. This is the OH, this hydrogen has been shifted, and this water has been removed. Yani ki this acid is giving this OH and this alcohol is giving its hydrogen. Therefore this water has been released. Now always remember this part, that which is combining with which, because it can be asked in the question. Let's see some of the examples. So in the examples we are, let's say, having that is RC double bond OH. It is combining with R dash OH in the presence of D plus. Now what will be the product? This D plus is mentioned only to confuse, because D plus has no role in this product one. This RCO will be combining with this R dash O. Therefore it will be RC double bond OR dash. That will be the product. Along with that water will be removed and D plus will remain. So this is a example. Another one, that is RC double bond OD. Okay, and with that we are having R dash OH. Now it can be asked what will be the product in this case. So this RCO combined with this R dash, this OD will combine with this hydrogen. So it is RC double bond OR dash, and instead of H2O we will be having HDO, hydrogen deuterium combined with oxygen. Along with that, H plus will be there. So this is a kind of question which can be asked, that what will be the final product in this case. Also we can have an example for this one, that is CH3COOH. Along with that we are having C2H5OD, and with that we are having H plus. So what will happen, this CH3CO combined with C2H5O, and this OH will combine with this D. So that is the product which will be CH3C double bond O C2H5. Along with that we will be having again HDO, and this H plus will be released in here. So this is the reaction. That was the third one, which is referred as esterification reaction. Now the fourth one is referred as Williamson's ether synthesis. So in this case we are going to synthesize the ester, so ether. So in this case ether is there. So reaction, that is we are having the alcohol in presence of sodium, it is going to form RONA. Along with that hydrogen will be released. Now this RONA which we are having, it will combine with some R-X, and then it will be leading to a ether. So this is the formation of ether, and along with that NaX has been formed. So this is a SN2 reaction, that in this case there is a substitution which is taking place. This X is removed and in its place we are having this OR group. So it is a substitution reaction. Now for the SN2 reaction, it should be like the table which we have done for alkyl halide. SN2 कब होता है, E2 reaction कब होगा. So for that we are having different tables. एक टेबल में हमने लिखा था कि कब किस इंटरमीडिएट रहेगा, या फिर कैसा प्रोडक्ट होगा, या फिर कैसा रिएक्टेंट होगा, कैसा बेस रहेगा, तब SN2 रिएक्शन होगा. सो इट डिपेंड्स कि कब किस तरीके का रिएक्शन होगा. ठीक है, तो इट विल डिपेंड on this R-X. Okay, R-X can be 1 degree, 2 degree or 3 degree. With 2 degree and 3 degree we are not going to get this particular ether. With 2 degree we can have, but it will be major and minor, it will be splitted. So we will write for this, but obviously for 1 degree there will be only SN2 reaction which will be taking place. So there is no issue with that. 1 degree that will give you SN2, but with 2 degree or 3 degree it can be E2 as well. So if this reaction goes by E2 mechanism, then it won't be referred as a Williamson's ether synthesis, because no ether will be obtained. We will be obtaining alkene as a product. Therefore this reaction will not be referred as Williamson's synthesis. Okay, so we can write for 2 degree, that in case for 2 degree we said that if there is 2 degree Rx, then we can have two mechanism, either it can be E2 or SN2. So if E2, then it gives the major product and SN2 will be giving the minor. So this minor one will be referred as Williamson's synthesis, because in this case we will be obtaining ether by substitution, and because of the elimination we will be obtaining a alkene. So if there is 3 degree Rx, so let's see an example for that. For 3 degree Rx we are having the example which is CH3 carbon, CH3 connected to a X group. Now we are adding the base in here, that is C2H5O minus Na plus. So it is a strong base. Along with that we are having a strong nucleophile as well. So it will lead to the product which is CH3 carbon, then CH3 and double bond CH2. That means a alkene has been obtained and HX is there. So this is the alkene, not an ether. Therefore this reaction won't be referred as Williamson's ether synthesis. Okay, so you should remember this one, that when is E2 and when is SN2. This one we have also covered in the chapter which is alkyl halide. Okay, so these are the reactions which are due to this hydrogen which is present in the alcohol, that is acidic nature of this hydrogen. Now the next one, that is next set of reaction, the second one, that is referred as reactions due to CO bond which is present. Now in this category we are having again 4 reactions which is referred as first one Grove's method, then the next one that is sixth referred as action with PCl3, seventh which we are having that is referred as action with PCl5, and the eighth one that is SOCl2. So these are the reactions which we are doing. So the fifth one that is Grove's method. So in this Grove's method, let's do the reaction. In the Grove method we are having basically the Lucas reagent, and also we have covered all these reactions in the alkyl halide chapter, so we are just repeating those part. You can also refer to those part that is done in alkyl halide itself. This is already covered. Lucas reagent is HCl in presence of anhydrous zinc chloride. This reaction is ROH in presence of HCl, that is acid H plus. It will be forming ROH2 plus, and this H2O will remove, therefore it will be forming 3 degree carbocation, and there will be Cl minus because HCl, H plus and Cl minus. So this Cl will combined with R plus and it will be forming a turbidity. Now this turbidity can lead to the analysis of which type of alcohol we are having, whether it is 3 degree alcohol, a 2 degree alcohol, or a 1 degree alcohol is involved in this reaction. So if it is a 3 degree reaction, therefore it will give turbidity immediately. That is, immediate turbidity will be obtained in this case. The second one, that is 2 degree alcohol, we will be having turbidity. It will also give turbidity, but it will be after 5 minutes. Okay. And the last one with this 1 degree alcohol, it will be giving turbidity, but this turbidity will be obtained on heating. So this is the Grove's method. Okay. Then the sixth one, that is action with PCl3. So with reaction with PCl3, if there is alcohol along with that PCl3 is there, it will be forming RCl, along with that H3PO3 will be obtained. And for this we have already done the mechanism in the chapter which is alkyl halide, so refer to that. Next is with PCl5. This is also done in alkyl halide. So I'm just writing the reaction. If there is alcohol in a reaction with PCl5, it is going to give us the product which is RCl, along with that POCl3 will be obtained. And the last one with SOCl2, that is ROH in a reaction with SOCl2, it will be forming RCl, along with that SO2 will be released, and along with that HCl will be released. For these three, the mechanism, refer it in the chapter which is alkyl halide preparations. So we have already covered those part. Now the next one, that is the next category which we are having, that is referred as the miscellaneous reaction. So the third one. Now for the third, we are having this miscellaneous reactions. So in this miscellaneous reactions, we are having this reaction which is referred as dehydration reaction. Dehydration means removal of water. First we will be writing the list of dehydrating agent. So in the list of dehydrating agent, we are having the first which is P4O10. Then in this one, the second one which we are having is referred as Al2O3. Then the third one, that is concentrated H2SO4. Fourth one, it can be concentrated H3PO4. Then the next one, that is fifth, it can be also referred as KHSO4. Then sixth, that is dehydrating agent, that can be POCl3. Okay. Then there can be CaO, which is calcium oxide and also referred as quicklime. Then the next one, anhydrous CaCl2. And the ninth one, that is referred as anhydrous ZnCl2. So these are the dehydrating agent. That means they will remove water from the system. They are going to remove water, and when they are going to remove water, whenever there is heat involved. So let's say we are having a alcohol which is C2H5OH, ethyl alcohol. In this case we are adding the dehydrating agent. Let's see what is going to happen. So we are adding concentrated H2SO4 at a temperature which is referred as 100 to 100 degree Celsius. So at this temperature we will be having the product which is C2H5HSO4, which is referred as ethyl hydrogen sulfate. So there is a temperature range that at different temperature different reactions can be taking place. So this is ethyl hydrogen sulfate. Then again we are having this concentrated H2SO4, but the temperature is a bit increased, that is 130 to 140 degree Celsius. Now in this case we will be obtaining ether, which is C2H5O C2H5, referred as diethyl ether. And the next one, that is again with the same thing, that is concentrated H2SO4, but the temperature is increased further near around 170 degree Celsius. So at this temperature, or it can be also referred as Al2O3 at a temperature of 350 degrees Celsius, it is going to produce a ethene. That means a removal of water will be taking place. So this is a ethene that has been obtained. Along with that we are having water. So this is a temperature dependent. At which temperature what will be the product, that is we have to remember. Okay, so this is a removing of water only in the last one. This is referred as a dehydration or the dehydrating reaction, that water has been removed in this case. Okay, so this was the 9th one, that is dehydration reaction. And the last and the final reaction for alcohol, that is very important reaction of alcohol, the 10th one, which is referred as iodoform reaction. You must always remember this one. This is also categorized as a name reaction, iodoform reaction. So in this iodoform reaction we are having, that is CH3 C double bond O. Let's say there is a group which is referred as R. So in the presence of a R group, or it can be hydrogen as well, hydrogen or the R, that is aldehyde or alcohol, aldehyde or ketone. So for aldehyde and ketone we are adding the reagent which is I2 and OH minus. Now this is a withdrawing group, C double bond O. What it does withdrawing. So this is a withdrawing C double bond O, oxygen more electronegative, it will pull the electrons towards itself. Therefore there will be deficiency of electron on this carbon, and along with that this is a hydrogen. So this hydrogen, this is a withdrawing group, it is pulling off the electron. Therefore carbon hydrogen bond in here, that gets weakened, and because it gets weakened, this hydrogen becomes acidic in nature. That means in presence of base this hydrogen can be removed. And how many hydrogens are just next to this C double bond O bond? That is 3 alpha hydrogen is present. So in presence of 3 alpha hydrogen which are acidic in nature, and in presence of a reagent which is I2 with a base can be KOH or NaOH, it will be forming a iodoform which is referred as CHI3. So this is the iodoform which has a yellow color, that is a yellow precipitate. Along with that we will be obtaining the product, that is hydrogen or this R group connected to C double bond O, and then we will be having O minus connected with Na plus in this case. So we are having this reaction. This reaction is referred as a iodoform reaction. Now let's look into the mechanism, that what is happening in this one. For the mechanism we are having this compound which is having 3 alpha hydrogen, so CH2 hydrogen, C double bond O, H or R. So this is a alpha hydrogen, 3 alpha hydrogen are there which are acidic because of this presence of C double bond O bond, that is a withdrawing group. Now in presence of base which is OH minus, this hydrogen will be removed. So we are removing this hydrogen. This will be CH2 with a minus charge and C double bond O with hydrogen or R group. Now there is iodine also present in the system, I2. This is delta plus delta minus. This iodine will attack, this minus charge will attack on the iodine, and I plus will be taken, I minus will be removed. So it will be CH2 with iodine, then C double bond O, hydrogen or the R group is there. Now if we continue this reaction, there are two more alpha hydrogen which are present in here. So these also can be interchanged by the iodine. What we have done, we have removed the hydrogen and we have inserted this iodine in its position. So if we do that in presence of base and iodine, that is repetition of the step, therefore all the hydrogen will be removed and we will be having iodines which are connected to that particular position. Now this Ci3 is a good leaving group, and again in the presence of base which is OH minus, it will attack at this position, this bond will be opened, therefore we will be getting Ci3 with CO minus, then OH, then hydrogen or the R group is there. So this minus will come back, this Ci3 group will be removed because it has become a good leaving group because of the presence of iodine in it. So we will be having, that is C double bond O, CH3 not H or the R group, then this OH is there, along with that this Ci3 is removed with a minus sign. Now next step is the proton transfer. This iodine will take this proton, okay, and this will be remained with minus sign, so it will become CHI3. Along with that we will be having O minus, C double bond O, which is connected to R group or the hydrogen. This minus will be attached with Na plus. If the system is having NaOH, then it will be attached with Na plus, or if the system is having K plus, it will be attached with K plus. So this is a salt. Along with that CHI3 has been obtained, which is having the yellow precipitate, which is also used as a test for aldehyde and ketone. Okay, so this is the reaction which is referred as the iodoform reaction. In this iodoform reaction, what we are having, that is we are reacting this particular acid, that is aldehyde or ketone with iodine in presence of a base which is OH minus, and we are obtaining the product which is CHI3. Now this is also applicable for alcohol, because this is the reaction which we have done in alcohol reaction. This reaction can also be extended to alcohol. Now you will be wondering, we are doing the reaction with ketone or aldehyde, but where is the alcohol? So let's continue this reaction with alcohols also. Now in case for alcohol, we are having one example. We have learned the iodoform reaction. Now example, that is we are having a 2-degree alcohol. So this is a 2-degree alcohol. Now we have taken NaOH in presence of iodine. So this is also oxidizing agent. Now how it is oxidizing agent? This with iodine or chlorine. Now this NaOH in presence of chlorine, it will react within itself and it will form NaCl, along with that NaClO. Now this NaClO again gets splitted into NaCl, along with that it provides nascent oxygen. Since it is providing nascent oxygen into the system, therefore it can be referred as a oxidizing agent. So this is a oxidizing agent. It will oxidize this 2-degree alcohol into a ketone. So in this case we will be having the ketone. Now this is the CH3. In the end what we are having, this is nothing but CH3 group. Therefore 3 alpha hydrogen, a C double bond O group, that is a withdrawing group. Therefore in presence of NaOH and chlorine, it will be doing a reaction, that is the positive reaction for this halo form. That can be the product in here, that is CH3. It will be replaced by this chlorine, that is CHCl3 will be the product. Along with that we will be having O minus and Na plus. So this is what? This is chloroform. that has been obtained. So this is similar reaction with the iodoform. The same thing, 3 alpha hydrogen double bond O, that is a withdrawing group, and again base taken with chlorine. So the iodoform reaction, it can be also extended by the name of haloform reaction. Either this reaction can take with iodine, chlorine, or with bromine as well. So haloform reaction. And what are the conditions? That is 3 alpha hydrogen should be there, along with that a withdrawing group, that is C double bond O bond should be present. Okay. Now similarly, the next example for this iodoform reaction only, the next can be, we are doing with reaction with C2H5OH, which is a 1 degree alcohol. Now in presence of iodine and NaOH, it will be oxidized, and it will be oxidized to a aldehyde. Now this aldehyde on reaction with further iodine and the base, that is I2 and OH minus, it will be forming Ci3 C double bond OH. Now again this group will be leaving, Ci3 group will leave, it is a leaving group. So iodine OH minus, it will be obtaining the final product, which is CHI3. Along with that we will be having O minus C double bond OH, with that Na plus will be attached. So this is a iodoform that has been obtained. So this is iodoform which has yellow precipitate. So this is that reaction. Similarly, we can have the another example, which is with, so there is benzene and there is OH connected with CH3. Now we are adding, this is I2 along with that NaOH. So again it will be oxidized to acetone. In this case we are having 2 degree alcohol. So 2 degree alcohol will be oxidized to acetone, and 1 degree alcohol will be oxidized to aldehyde. So this is a oxidizing agent because it provides nascent oxygen to the system. Therefore it will be C double bond O CH3, and there is 3 alpha hydrogen, there is a withdrawing group, that means positive iodoform test will be given. We will write CHI3 will be product, therefore we can write positive iodoform test has been obtained. So these are the reactions for alcohol. So for the alcohol one, we have covered total of 10 reactions. What are the 10 reactions? The first one, that is because of the reaction due to OH, that is due to this acidic hydrogen, we were having 4 reactions. Okay, then similarly the next category, which is reaction due to CO bond, that is Grove's method, then PCl3, PCl5 and SOCl2. So there were the 4 reactions, and in the miscellaneous one we were having 2 reactions. The first one referred as dehydration reaction, the second one that is referred as the iodoform reaction. Among these, the most important reaction is referred as the iodoform reaction, which is also referred as a test of test of aldehyde and ketone. But some of the alcohol also give this reaction, like 2 degree alcohol, 1 degree alcohol can also give this reaction. Okay.